Hi everyone, and today we'll be discussing some vector operations on a scalar quantity on a or on a vector, right? So phi is a scalar, a is a vector, right? So first we will be discussing gradient. Okay, so if you operate that on any gradient, any scalar function, we'll be getting a vector, right? So obviously it's a vector operation. Okay, so once you operate grade on scalar, you will be getting a vector, right? So then the divergence, okay? Divergence here, divergence there is a dot here. You can distinguish this grade from gradient from this divergence from this dot, right? So then we have a vector operator and we have a, it's a vector itself, right? So if you take a dot product. Right? So here we have a formula I dou by dou x plus j dou by dou y plus k dou by dou z, and there is a a there. So this is the formula. Then we have a curl. So here del is also a vector operator, a is also a vector operator. So a is also a vector. So here is a formula for the curl. Right? So here we have a first problem. So we have a gradient, right? So we have a gradient and find the gradient of the scalar at the point 1 comma minus 2 comma minus 2. This is taken as x, y and z, right? So del phi is equal to I dou by dou x plus j dou by dou y plus k dou by dou z. Then we have 3x square y minus y cube z square. Right? So that we have to take gradient for this. Right? So as a result of that, we will be getting a vector, right? So this is a unit vector is here. So 6xyi and 3x square minus 3yz square. Just you are differentiating with respect to x here, with respect to y here, and with respect to z here. On differentiating with respect to x, here we have only x term in this first term. So you will be having 6xy, and next for j we will be having uh, you have y in both the terms, so you'll be getting 3x square minus 3y square z square, and we have dou by dou z is on second term only, then there is a minus sign there, so we have y cube as it is and 2z is here. Okay, then they asked grade phi at the particular point. So we have to substitute the values of x, y, z in the obtained gradient value, right? So instead of x and y, you just put the values of x, y, and z. You put the values of 1, minus 2, and minus 1 respectively, and you will be ending up with this. So this is the gradient of the given scalar quantity. So this is the next problem. Here, this is the problem which was asked in IIT Jam. Right? So if f is the constant vector and r is the position vector, then find del f dot r. So here we have dot product, and you will be having a gradient operation here, right? So you don't observe any dot in between this two terms, but you have f dot r dot here, f dot or f vector dot r vector. If you take dot product of two vectors, right, you will be getting a scalar, right? So I can write in general, I write f is equal to f naught. As I told, it has a constant. F is equal to I plus j plus k. So f naught is a number. I, j, k are unit vectors. Okay, uh, it's a general formula. And for our position vector, we are denoted by x, y, and z. Obviously, unit vectors can be written as I, j, and k. To take dot product f dot r, obviously we will be getting a scalar. So f into, which is x plus y plus z, and we have gradient formula here. I dou by dou x plus j dou by dou y plus k dou by dou z, and f naught x plus y plus z. If I take a gradient, I will be getting f naught I plus j plus k. These are unit vectors, so this is the constant value, which is nothing but f. So the value of del gradient of f dot r, f vector dot r vector is nothing but f, which is nothing but f, right? So that will be the answer. So if you want to find the This is the this is unit normal is usually asked in most of the cases. So unit the vector the unit normal in order to find the unit normal vector, the formula for this is del phi by grade sorry modulus of del phi, and here they gave the surface in this problem. This is the second problem, right? This is completely new, right? Even they will give surface, and from that you have to find the gradient. Okay, so they gave the surface. Obviously, if you plot this, okay, just type this equation in Mathematica or from Alpha website, and you are able to get the surface x square plus y square equal to z at a point 1 comma 2 comma 5. Okay, then you have to find the uh, unit normal for us. Okay, so we will do this conceptually. What is my unit normal, unit vector, gradient? Okay, physically you can understand. For the time being, go with the formulas. I will try to give the visualizations in the upcoming videos. Right. So here we have del phi. So obviously phi is nothing but the surface. Obviously this is the scalar. So I dou by dou x plus j dou by dou y plus k dou by dou z. Here we have x square plus y square minus z. And once I differentiate with respect to x, y, and z, I will be getting 2x, 2y, and here we have minus z as instead of that minus 1. Okay, so here we have this, and we have to find the gradient at a point 1 comma 2 comma 5 in order to find the normal, right? So here we have the gradient at y. Instead of x, put 1. Instead of y, put 2. And instead of, there is no z here, so it will come as it is. So the unit normal vector del by modulus of del phi. So 2i plus 4j minus k, the square root of 4 plus 16 plus 1. I just squared this, right? So the unit normal vector is written like this, right? So 2i plus 4j minus k divided by root 2 1. This is the unit normal vector for the given surface x square plus y square equal to this. Okay. So if you want to visualize this, use Mathematica or Wolfram Alpha in order to get the visualization. Okay. Here we have another problem on vector algebra. Okay, this formula requires only knowledge about the dot product of two vectors, right? So a unit vector perpendicular to the plane contained. Okay, they gave two vectors. Okay, they the options they gave us gave as given as unit vectors. The options are unit vectors, right? And we have two vectors, and we have to tell whether these two vectors are perpendicular to this unit vector or not. So that is the question, right? So what will happen? So let's understand the idea mathematically. Right? If we have two vectors, we take a dot product, which is ab equal to ab cos theta. This will become, if two vectors are perpendicular, that means theta is 90 degree, right? Obviously, if we have a vector and b vector, and if theta is 90 degree, then only two vectors are perpendicular. If we put cos 90, then this term will become 0. So a dot b equal to 0. As a result of that, if you take dot product of two vectors, if it becomes 0, then two vectors are perpendicular. Okay, that's the simple idea. And if two vectors are parallel, obviously the maximum value, that is cos theta, will become 1. So you'll be getting the maximum value, right? So in order to check the parallel vectors, you can use this in order to check whether the vectors are perpendicular or not. You can check this, right? So if I take option A, we are going with the option. Right. With the help of this option, what we do, we just take a dot product with A and B. Okay. If I take a dot product, I will be getting a number. I am getting a number. Okay. So obviously these two vectors are not perpendicular. Okay. Then I am choosing option B. Okay. I can see by seeing the vectors itself, I am able to tell if I take a dot product 1 into minus 1, which is minus 1, and 1 into 5, minus 5, which is minus 5, minus 2 into minus 3, you will be getting 6. So this terms becomes zero, right? If I take an option and I take a dot product, the numbers will become zero. Automatically, the dot product will become zero. So that's why I chosen this D. And if I take a dot product, I will be getting minus 1, minus 5, and plus 6. This is obviously 0. This is true for the A vector. Similarly, for B vector, if I do that, I will be getting 0. Okay. So this is the one of the problems which was asked in IIT exam. Okay. So you can try some other problems like this. Okay. Okay. Let's see some more problems in upcoming videos.